Okay, so welcome to this tutorial on ions and ionic bonding. So we're getting a little bit more complex now from previous videos. So last video we looked at atomic structure and we looked at these basic things here. So just to sort of refresh our memories, we have got in this area here, we have got, this is called the nucleus. This is the nucleus. It's the center of the atom, and in there we have got protons, which are positively charged, and we've got neutrons, which are neutral, they have no charge on them, and in this thing here, which we call a shell, or an orbital, or an energy level, so all the same thing, we have got these things called electrons, which have got negative charges on them. And if you remember, the number of protons in something equals the number of electrons in a neutral atom. Okay, so if there are 2 protons, there are 2 electrons. If there are 100 protons, there are 100 electrons. So that was the first thing that we did. We also looked at symbols here, and so for example, again, we've got helium as an example here, and we've got this number down the bottom of our symbol there, that 2, which is our proton number, which tells us how many protons are in our atom. Now remember, that also tells us how many electrons are in it, because the number of protons is always equal to the number of electrons in a neutral atom. Number of electrons. And we also have this number up here, which is our mass number, which is the number of protons plus the number of neutrons in the nucleus. Okay, so that was that. And we also looked at how to draw this in a simpler form, our electron arrangement. So, for example, we've got 2 protons, so I'm just going to write 2p. We've got 2 neutrons as well, so 2n. And we've got 2 electrons. And if you remember, we represented electrons with crosses in our shells. So this is where this information really comes in handy. So we're going to look at couple of other examples here. So we're going to quickly skim through these, and these are going to be our examples that we're using for this activity then. So we've got sodium here, we've got a proton number there of 11, so if there are 11 protons, then there must be 11 electrons as well. So we're just going to skip straight ahead to the electrons. That's what we're focusing on today with ions and ionic bonding. So we've got 2 in the first shell. Remember, that shell is now full, so we've got to move up to the next one. 1, 2, 3, 4, 5, 6, 7, and 8. Remember, I'm drawing those on the line, and I'm drawing them on the north, south, east, west axes on there. So they're not just wherever the heck I want them to go. Right, now for this, I haven't finished that one actually. So there's 2, there's 8, so there should be 11 in total, so I need an extra 1, and I'm going to put that, let's put that here. Okay, so I've got my electron there in the outer shell. Now, this bit's quite important now. We need to know a little bit more about the structure of the atom and another phrase. So we've already said that this outer shell here, all these shells are called energy shells or orbitals or shells, orbitals, or energy levels. So we're going to look at another name for this outer one here, this one here, and this is called the valence shell. The valence shell. Valence shell. It's because that's the outer shell. So you can see here that in our valence shell we've got 1 electron. Right, let's go over to chlorine for a minute then. We're going to go over here and look at this. Now, for the sake of this activity, we're actually going to be using dot cross diagrams for this. Dot cross diagrams. That's what we use to show ionic bonding. So I've used crosses over here, so surprise, surprise, I'm going to go for dots over here. So this time I'm going to use dots to represent our electrons. So we've got 17 is our proton number, so if there are 17 protons, then there are 17 electrons. So I've got 1, 2 in the first shell, so that's full. 3, 4, 5, 6. There we go. 8 there, so now we've got 2 8s, that's 10, so I've got 7 left over. So 1, 2, 3, 4, 5, 6, and 7. Right then, so that is chlorine then, and you can see again that in our outer shell, which is our valence shell, whoop, that's not good. In our valence shell, oh no, oh effort. Hey, okay, so in our valence shell there, our outer shell, we've got 7. So that's quite important here. So in this one, we have got 1 outer electron then. So 1 outer electron. And in chlorine, we have got 7 outer electrons. Now, if you look at what groups these things are in, you actually find that sodium is in group 1 of the periodic table, and chlorine is in group 7. So this group number tells us how many electrons are in this valence shell, how many are in this outer shell. Now, atoms are a little bit OCD in terms of their structure. Now, by that, what I mean is that they like to have full outer shells. So, if an atom had the choice, it would rather have 8 electrons in its outer shell or none, which we're going to look at in sodium in a second. So, they want full outer shells, basically. Now, sodium, if you have a look at sodium, would be very happy then to lose this electron. To lose that, so that electron has now gone. Okay, so it loses that electron. By losing that electron, we lose the actual valence shell here. So instead, we produce an ion. So we're going to draw the ion here then of sodium. So in losing this electron now, we've actually cleared this outer shell here of sodium. So the valence shell, or this valence shell at least, has now disappeared. Slowest rubbing out ever. Okay, so that's disappeared. Now, we have now got a new valence shell. A new valence shell. That's here. So that's our new valence shell. And you can see it's now got 8 outer electrons. So it is happy. It has got a full outer shell. So you know that electron hasn't just disappeared. We're going to look at where that's gone in a second. Okay. Now, because this is an ion, which is different to that, we represent that by putting that into square brackets. So this shows it's an ion. Now, it's also changed its charge because it still has, in its nucleus, it still has 11 protons. However, if you have a look, we've got 1, 2, 3, 4, 5, 6, 7. We've actually got 10 electrons now. 10 electrons. Oop, that looks like 16. That should be 10. 10 electrons. Now, that means we've upset our balance here. So imagine kind of like a weighing scales. So we've got 11 protons, 10 electrons. We've got more protons than electrons. And so for that reason, this gets a charge of +1. Okay, so sodium, when it becomes an ion, is a positively charged ion. So if we want to write that differently, we would write Na+. So that is an ion of sodium. Now we're going to redraw. Let's have a look at chlorine now. Let's have a look at how chlorine likes to form an ion. So again, it wants to have a full outer shell. To do that, it's got to gain an extra electron, because one more electron, it would have 8 in its outer shell, and it would be happy. So this then is going to show us how we draw our chlorine ions. So now this electron hasn't just, the new electron is going to gain, is not just going to come from anywhere. Okay, it's going to come from somewhere. So for this reaction, it's coming from the sodium over here on the left. So this one over here that's been lost is now going to, this is going to look terrible now, but it's going to come all the way over here, and it's going to plonk in that shell there. So this is the importance of dot cross diagrams, because this electron, this X here, shows me that that electron has come from this sodium atom. And that's why we do that. We're going to represent it again in the same way, so we're going to put that into square brackets, because that's how we show that it is an ion. Now in this case, we've got, or chlorine has got 17 protons in the nucleus, because the number of protons hasn't changed at all. But it's now got 18 electrons. So it's got more electrons than it's got protons. Electrons are negatively charged, so the charge of the atom is now changed, and it's become negative. So we're going to represent this as Cl-. So these are our ions that we formed. So we formed Na+ and Cl-. So we've got Na+, and we've got Cl-. Now if you have a look, we've got a charge of +1 here. I'll just put in the -1 and the +1 just for clarification. So we've got +1 there and -1 now there. Now for these things to react and be able to stick together, those charges have to balance out, because these atoms behave a little bit like magnets. So these charges are kind of like the charges you get on a magnet. So we've got like a plus end here and a minus end there. Now, if those are apart like this, what's going to happen is that the opposite charges are going to attract, obviously. And so the negative side of our magnet, as it were, is going to come and stick to our positive. Now with magnets, once those things are stuck together, they're quite difficult to pull apart. And so it's the same with ionic compounds. Once those compounds have become attracted to each other, it's quite difficult to pull them apart. So in this case, those charges do in fact balance out, and we get, so this forms NaCl, a nice neutral compound. So you can see that sodium has lost an electron, it has given an electron over to chlorine, the chlorine's accepted it, it's changed the charges on the atoms, it's formed ions. So an ion, so if we're talking about in terms of definitions now, an ion is a charged particle. A charged particle. So it's got a positive or a negative charge in it. That is what an ion is. You need to know this. Okay, so an ion is a charged particle. So as you can tell, sodium is in group 1 and is an alkali metal. And so, so ionic bonding, if we're going for a definition here, ionic bonding is between a metal, for example here we got sodium, a metal, and a non-metal. In this case that's chlorine, non-metal. The non-metal is always negatively charged and the metal is always positively charged. And so this is ionic bonding. Ionic bonding, which comes about from the formation of ions. So we're going to quickly skim through another example here. So as you can see, we've got Na+, Cl-, the charges balance out, so we get this neutral NaCl. Now, what about if these charges are different? If instead of +1, we've got +2, or instead of here, we had -1 or -2. So we're going to look at another example here. We've got magnesium. We're literally going to fly through this one now. So we've got magnesium, and here's its valence shell, as we've done again, to show its outer shell over there. So we've got a proton number of 12 for magnesium, so that means 12 protons and 12 electrons. So 1, 2, that's full, 4, 7, 8, 9, 10, that shell's full now, 11, and 12. So this one's got 2 in its outer shell, 2 electrons in its outer shell. Now, so the magnesium ion that's going to form, magnesium, again, it wants to have a full outer shell. And so to do that, it's got to lose 2 electrons so that it can have this 8 electrons in its outer shell here. So it wants to lose these 2 electrons. Now, chlorine, again, only wants to accept 1. So let's say now that one of these electrons goes over here to chlorine. So there it is. Now, we've still got a problem here of having an extra electron left over there. So in the case of magnesium, then, we need another chlorine atom. So there's my second chlorine atom. So this electron now is going to go down and join this one. So again, this is the importance of the dot cross diagram because it shows where these electrons are coming from and going to. So this one then, my magnesium, again, remembering now ionic bonding between a metal, which is positive, and a non-metal, which is negative. We're going to form, and I'm skipping out the drawing the ion phase here because I just want to get through this quickly. So we've lost 2 electrons. Remember, electrons are negatively charged, okay, negatively charged. So we've lost 2 electrons. So the magnesium ion then, Mg, is going to be 2 plus because it's lost 2 electrons, and so it's got an overall charge of +1. Now the chlorine has got still got a charge of -1 because we've only got 1 there. But we've got 2 of these chlorine atoms, so it looks like this. Okay, Mg, and then 2 of these. Now, over here we've got a total overall charge then of 2 plus, and over here we've got an overall total charge of 2 minus now, so we've got 2 of these. So the formula for magnesium chloride is MgCl2 rather than MgCl. And again, this is an ionic compound. Ionic compound. And we've got our metal here, which is our magnesium, and we've got our non-metal, which is our chlorine. We've got 2 of those. And so that little 2 down here tells me that I've got 2 chlorines in there. Okay, so that is a little bit about ions and ionic bonding.